Namaste everyone. Welcome back to Mrs. Mohan's class. Today we will be discussing the remaining 5 questions of the concept builders. Now before going into that, I would like to start today's class with apologies for an error that was committed in discussing the first question in the previous video class. And also with a big thanks to Shreya Mishra for bringing to my notice the error that I had committed. Thanks to her once again and apologies once again. I'm going to correct it today. So kindly, ignore what was done in the previous lecture only with regard to the first question, please, and not with regard to any other question. There was an overlook from my side and I had given the directions wrong. So let me do it once again. And before going into that, I'm going to put up all the 12 on the screen so that we get to know the difference. When the current direction changes, the field direction also changes. Is that clear? So let me go into it, please. This is the correct answer, and the answer that was discussed, again, a humble request. It was an overlook from my side, a slight error, so kindly change it. It was only the first question and not the other questions. So let's go into the first question once again. And we apply Ampere's thumb rule, and we move on to apply that rule to find the directions of the magnetic field in various cases. So if you look at the first one, it goes into the plane of the paper. So let me pick up my pen. It goes into the plane of the paper above and out of the plane of the paper below. Right? This is also a very easy way actually of determining the direction of the magnetic field. This is a legal way of representing it. If I'm going to simply put crosses and dots. So crosses shows that it goes into the plane of the paper and dots show that it is coming out of the plane of the paper. So this is much easier. You can simply put crosses and dots because you know that this is where it moves in and this is where it comes out. So if I'm going to hold it like this, this is where it moves in and this is where it comes out. So this is also one way of doing it. But since I started off with doing concentric circles, so if you look at the first one, it moves in and comes out over the wire. So it moves in and comes out over the wire. So if you look at the concentric circles, and if you look at the arrow marks that we are moving, that it is going to be in the anti-clockwise direction. That was the error I made. I said it is going to be in the clockwise direction. So please get it corrected. I have corrected myself. You will also correct it. It was an overlook while applying the thumb rule. So please correct it. Now I'm going to look at it in a different way when I'm going to discuss it today. I'm going to look at it in pairs. Look at 1 and 7. 7 is going to move from down to up. Is that clear? So it is going to move from down to up. So if I'm going to put the concentric circles here, it is going to move, if you look at the direction, it is moving in the clockwise direction. So it's anti-clock in 1 and clock in the 7. Now look at 4 and 10. It is moving from, if you're going to move, it is moving from left to right. So if you're going to move from left to right, and if I'm going to make concentric circles, you are moving in the clockwise direction. Whereas look at number 10, you are moving from right to left. So you're moving from right to left. If I'm going to make concentric circles here, so I'm moving from right to left. So I'm moving in the anti-clockwise direction. Now let's look at is it 5 and 11, if I can take it as opposite to each other. If you look at 5, it is moving from down to up, left down to right up. So it's moving from left down to right up. Whereas if I'm going to look at 11, right up to left down, right? It is moving from right up to left down. Correct, children? So what else are the pairs? Can I say 3 and 9 are the pairs? So I'm going to pick 3 and 9 now. 3 and 9, you're going to hold it like this. So up to down. You're going to move from up to down. Correct, children? Right? So if I'm going to move it in this direction, I'm going to move like this. Whereas what did we say is a pair? So if I'm going to move on 9, it's going to move like this. right? You can see that the direction of the magnetic field is going to reverse when you are going to reverse the direction of the current. Is that clear, right? And then what can we pair up with? I think 2 I can pair with 8, right? So 2 I can pair with right. So 2 you are going to hold from up to down, over the conductor, up to down. Whereas if I'm going to look at 2 and 8, it's going to be from down to up. And if I'm going to look at 6 and 12, down to up and up to down. Is that clear, children? So kindly have a look at it and correct yourself and ignore what was discussed in the previous lecture, but only with respect to the first one. All the remaining 4 questions were right with respect to the directions. Now I'm moving on to the second question. Before going into the second question, I would like to go into the, I think it is the 9th question, so that the rule that we are going to use in the second question will be much clearer. So what's the rule that we are going to use? We are going to use FBI, Fleming's left hand rule. Mutually perpendicular, please let's get that very clearly. Mutually perpendicular directions. The thumb shows the direction of the force acting on the conductor, forefinger shows the direction of the magnetic field applied, and the middle finger shows the direction of the center finger. I'm sorry for it. The center finger shows the direction of the C4C, the current. Now, when I'm going to be showing these fingers, children, please understand that my image, as you are seeing, is going to be laterally inverted. Is that clear? The camera is laterally inverted. So I will be actually showing east in my room, but when you are going to get that video, you will feel that I'm actually showing west. So get that corrected. Don't look at my figure. Look at what I'm explaining with respect to your question and what I'm putting as an answer, and see if your fingers match the answer that I'm going to talk about. Because if I'm going to try and show the opposite direction, my finger will give me a wrong answer. In order that my thumb shows the correct direction, I am going to show the right direction in my room, the correct direction in my room, which will be laterally inverted for you. That was also one of the reasons clockwise became anti-clockwise in my first answer. But no excuses given for the error that was made. I stand corrected. So let's move on, and please understand when I'm going to show west and east, up and down will not remain, will remain the same. West and east will remain different. So kindly get that clearly. Look at your fingers and see if your answer matches what I'm going to give you. So let us remember FBI, and let us also remember that they have to be mutually perpendicular to get the answers. So I'm going to the first subdivision of the second question. Electron moves from west to east. That means my current moves from east to west. Please get that very clearly. My current is going to move from, this is the east for me, and this is west. Okay, on the board you will look east and west, right? In the plane of the paper, magnetic field is directed inward, perpendicular to the plane of the paper. Get this very clearly. If field is perpendicular, force is in the plane. If field is in the plane, force is perpendicular to the plane. Get this very clearly, because they are mutually perpendicular to each other. So I have to show my current in the western direction and the field in the inward direction. So this has to be inward into the plane, and my current is in the western direction. So in the room, I'm showing west, and to the paper, that is to my laptop, I'm showing into the plane of the paper. So where is my thumb? Up and down remain the same. So my thumb is showing down. For you also, it will be showing down. So that means the force on the charged particle is going to be in the downward direction. So what am I going to write over here? Downward direction in the plane of the paper. In the plane of the paper. So downward direction in the plane of the paper. Is that clear, children? I hope it's clear. So let's see, let's see what we can do with the next question. Electron from south to north. That means where is the current, children? Where is the current? The current is from north to south. South to north, north to south. That means my electron, that is the current, is going to be in the downward direction. Field is from west to east. That is, it is going towards my right. Right is my east. So it is going towards my east. So current in the downward direction, field is in the plane. Watch this. Field is in the plane towards the eastern direction. So where is this? This is coming out of my laptop. The thumb is coming out of my laptop. That means it is going to be in the outward direction. Outward. Remember, field is in the plane. So that means force is perpendicular to the plane of the paper. Right, perpendicular to the plane of the paper. Hope you are understanding, children, because here field is perpendicular, field is in the plane, so force is perpendicular. In the previous question, field was perpendicular to the plane of the paper, so force is in the plane of the paper. Get that very clearly. This is a small tip that you can remember and you will not make an error. And remember, you are to state whether it is in the plane or perpendicular to the plane of the paper. Now look at the third subdivision, children. They say electron is moving south to north. That means current is north to south, downward direction. Magnetic field is also north to south. That means two of my fingers are in the downward direction. Is it allowed? Will you have a force? No, you will not have a force, because for a force to act, they should be in mutually perpendicular directions. So what am I going to write here? No force. Why is there no force? Since field and current are parallel to each other. Field and current are parallel to each other. There will be no force that will be experienced by the charged particle. Now look at the last question. Proton is going to move. Oh, sorry. I'm erasing off the answers. So let me be a little careful and erase. Okay, I will leave it off because I will leave it as it is. A proton is moving from south to north. That means current is moving in the upward direction. Field is directed outward perpendicular. So obviously force is going to be in the plane of the paper. So let's look at how it is going to be. Field is going to be outward and proton is moving from south to north. So I'm going to keep my finger like this. Do you see it, children? Current, you can see my center finger moving up. You are not able to see my forefinger. That's because I have pointed it out of the laptop. It's coming towards me. So where is my thumb, children? My thumb is pointing to my right. That means my right is my east. So where is the force? So the particle will be pulled towards the eastern direction. So it is going to be eastern direction. And is it going to be perpendicular or in the plane, children? You're right, in the plane of the paper. Is that clear, children? Yes. Right, eastern direction in the plane of the paper. Is that clear? So hope the second one is clear. We are moving on to the third question, which is a solenoid. You should be easily able to answer this question. We are going to use clock rule. So we know that if the current is going clockwise, it is south pole. Anti-clockwise, it is north pole. So if I'm going to apply that, obviously this comes out to be south and this comes out to be north. Is that clear? So because here, if you look at it, it is clock, and here you see it is coming in the anti-clockwise direction. So south and north. So how am I going to draw my magnetic field lines? I'm going to magnetic. So here they will be in concentric circles, and it has to move from north to south. It has to move from north to south. Whereas within the conductor, within the solenoid, if I'm going to see, I'm going to have lines. Sorry, I'm going to undo that line. Bear with me for my lines, children, because I'm using my free hand to draw, right? So I have lines moving into the south pole here and out of the north pole here, right? So south and north, you have to mention the polarity. You have to draw the arrow marks on the magnetic field lines. You can draw much better than what I've done on the board, but the most important thing is the polarity and the direction. So what happens when a soft iron core is introduced? We discussed this also in the lecture where we did the solenoid. That means it is going to increase the strength of the solenoid, behaving like an electromagnet. And then a single straight wire does not produce a strong magnetic field. The answer is also in the same video where we discussed solenoid. So if we look at there, solenoid is made up of more number of turns. So each of the loop will create its own magnetic field, which are going to be added up, increasing the strength of the solenoid. But when I take it as a coil, A straight wire has only one set of concentric circles, whereas when I take it as a coil around the soft iron core, which can be easily magnetized and demagnetized. So the soft iron's magnetic field also gets added up, and the coil, the number of loops around the coil also adds up to the magnetic field, increasing the strength. The behavior has been investigated in our video lecture when we discussed about the principle behind a current carrying solenoid. So go back and watch it once again. You will get the idea very, very clearly, right? So I'm moving on to my next question. Fourth was dealt with in the previous class. Fifth one, I think you're going to do it very easily right now. Current is my center finger, which is moving out. So I'm going to place it like this. Current is moving outward, and my forefinger is moving from my right to left. So you can see that the thumb is pointing in the downward direction. So that means the force on the charged particle is going to be in the downward direction. Now look at north and south here. North and south is in the downward direction. Current is in the western direction. So you can see my forefinger is in the downward direction. West, that is from my right to the left, is west for me. So current is in the western direction. So I can see that the thumb is towards me. It is coming out of my laptop. So my direction is going to be outward. And since the current is in the plane of the paper, the field is in the plane of the paper, the force is going to be perpendicular to the plane of the paper. Now look at the third case. Magnetic field is towards the east, that is from my left to the right, it is towards the east, and the electron beam is downward. That means my current is in the upward direction. Do you see this, children? Current is in the upward direction. So where is my thumb showing? My thumb is moving, my thumb is moving into my laptop. That means it is moving inward. So that is here outward perpendicular, here it is going to be inward. Again, field is in the plane of the paper. So my force is going to be perpendicular to the plane of the paper. I hope this would have been very easy for you. Let's move on to the next question after the fifth question. 6 and 7 was done. That's going to be the 8th question because 10th one was already done. Let's move into the 8th question. Look at this. The magnetic needle itself is a magnet, you know that, and the arrow mark actually shows the north pole of the needle. So the north pole is pointing towards the left. That means obviously X has to be north pole. That is when it would have repelled the north pole. So this is north and this is south. So obviously the magnetic needle will always seek the south pole. So the needle direction will be given like this. This is how you should have drawn in your papers. Now look at the second subdivision. Current is moving in the downward direction. That means my field is moving in the clockwise direction. So I'm going to move clockwise now. Clockwise. So it is moving in the clockwise direction. Now look at the third one. Current is perpendicular to the plane of the paper. That is, current is moving in. So how are your fingers wrapping? On the right hand side, it is going down, and on the left hand side, it is coming up. Please understand, children, your thumb will go into the laptop, into your screens, right? Because current is flowing into the plane of the paper with a dot. So that means on the right hand side, it is moving down. The magnetic field, because current and magnetic field are perpendicular. So the current cannot go in, the magnetic field cannot go into the plane now. That means current and the field will become parallel. So current is into the plane of the paper. So field is in the plane of the paper. So that means on the right hand side, it is moving down, and on the left hand side, it is moving up. So I will put a downward arrow here, and I will put an upward arrow here. Is that very clear, children? 10th question we have done. So that means we discussed second question, third question, and then what else did we do, children? Let's move back and see. We did 8, we did 5, 3, 2, and 9. We did 9 also today. So the 5 questions that was done today with the correction for the first question. So please have a look at it, watch it carefully so that there will be no errors, neither from my side nor from your side. I also close again with a note of apology. Please stand corrected. I have stood corrected, you stand corrected. And again, thanks to the child for bringing it to my notice. I appreciate that you are watching it intently and you are coming back to me for your doubts. Keep doing the same and get back to me for further doubts or clarifications. Till then, stay safe.